Implementation of Rocket Lab's Electron launch system by 2024. Executive Summary. Rocket Lab, a prominent player in the aerospace industry, is poised to enhance its Electron launch system by 2024. This initiative is structured into 4 key development phases supported by a substantial investment strategy of $100 million aimed at increasing the payload capacity of its Electron rocket by 25%. The focus of this report is to detail the development phase's investment strategy, market context, competitive landscape, and the timeline of events leading up to the launch of the upgraded system. Development phases. 1. Research and Development 2023. The first phase of Rocket Lab's strategy involves significant investments in research and development. The primary objective during this phase is to innovate and refine the technology of the Electron rocket. Key areas of focus include enhancing propulsion systems, developing advanced propulsion technologies that can support larger payloads while maintaining efficiency. Reusable components, creating reusable components that can drastically reduce launch costs and improve turnaround times between launches. This phase is critical as it lays the groundwork for the subsequent testing and validation of new technologies. 2. Testing and validation 2023 to 2024. Following the R&D phase, Rocket Lab will engage in rigorous testing to validate the innovations developed. This includes static fire tests, conducting tests on the ground to ensure that the rocket's engines perform as expected. Flight tests, executing a series of flight tests to demonstrate the capabilities of the upgraded Electron design in real-world conditions. The validation process is essential for ensuring the reliability and safety of the rocket before full-scale production and market deployment. 3. Production and Scaling 2024. Once the testing phase is complete and the technologies have been validated, Rocket Lab will scale up production. This phase includes optimizing supply chain management, enhancing partnerships with suppliers to ensure timely delivery of components and materials, increasing manufacturing capacity, investing in new facilities or upgrading existing ones to meet the anticipated rise in demand for launch services. This will enable Rocket Lab to ramp up its operations and prepare for the expected increase in launch frequency. 4. Market deployment late 2024. In this phase, Rocket Lab aims to officially launch the upgraded Electron rocket with its enhanced payload capacity. The deployment strategy will focus on targeting emerging markets, identifying and capitalizing on new market opportunities, particularly in the small satellite sector. Expanding client base, engaging with a diverse array of clients including commercial entities, government agencies, and international markets. By the end of 2024, Rocket Lab expects to solidify its position as a leading provider in the competitive space launch market. Investment strategy. Rocket Lab's $100 million investment strategy is primarily directed toward R&D and technological enhancements. This investment is crucial for maintaining competitive pricing. By innovating and improving efficiency, Rocket Lab can offer competitive pricing in a market where clients are increasingly price sensitive. Enhancing technological capabilities. Ongoing investment in technology ensures that Rocket Lab can keep pace with competitors like SpaceX and other emerging startups. This strategic investment reflects Rocket Lab's commitment to innovation and its determination to maintain a leading edge in an increasingly crowded market. Market context and competitive landscape. The global space economy is on a trajectory to grow significantly, with projections estimating it could reach approximately $1 trillion by 2040. This growth is driven by both commercial and governmental demand, particularly for satellite launches. Rocket Lab's Electron rocket, priced at around $7.5 million per launch, positions itself as a cost-effective alternative to larger competitors like SpaceX, whose Falcon 9 launches typically cost around $62 million. Key competitive forces. 1. Bargaining power of suppliers. Rocket Lab collaborates closely with a limited number of specialized suppliers for critical components, making supplier relationships vital for innovation and cost efficiency. 2. Bargaining power of customers. As the market expands and competition increases, customers have more options and can negotiate for lower prices. Rocket Lab's diverse client portfolio helps mitigate risks associated with this bargaining power. 3. Competitive rivalry. The aerospace sector is characterized by intense competition, with both established firms and new entrants vying for market share. Continuous innovation is essential for Rocket Lab to maintain its position. 4. Threat of substitutes. Alternatives such as air launch systems and emerging technologies are potential threats, necessitating continuous innovation to stay relevant. 5. Threat of new entrants. Although high capital requirements and regulatory challenges create barriers to entry, innovative niche players could disrupt the market, making Rocket Lab's established relationships and technological expertise crucial. Timeline of events: 2017 to 2023, Rocket Lab invests over $100 million in R&D to enhance its launch capabilities. 2023, initiation of the R&D and testing phases for the upgraded Electron system. 2024, planned scaling of production and market deployment of the enhanced Electron rocket, targeting increased payload capacity and frequency of launches. Conclusion: Rocket Lab's strategic roadmap for the implementation of its enhanced Electron launch system by 2024 showcases a well-structured approach to innovation and market responsiveness. The phased development strategy, supported by a significant investment in technology, positions Rocket Lab favorably within the competitive landscape of the aerospace industry. By addressing evolving market demands and emerging competitive pressures, Rocket Lab aims to solidify its status as a leader in the growing space launch market. Counterintuitive information identified in the content relates to several aspects of Rocket Lab's strategic positioning and the aerospace industry landscape. 1. Investment in R&D versus competitive pricing. While Rocket Lab is investing $100 million to enhance its Electron rocket, which includes improving its payload capacity by 25%, the paradox lies in the fact that this investment is essential for maintaining competitive pricing. Typically, one might assume that increased investment would lead to higher launch costs. However, Rocket Lab's strategy focuses on cost efficiency and innovation that could ultimately lower costs per launch. 2. Low launch costs versus high capital requirements. Rocket Lab's Electron rocket has a launch price of approximately $7.5 million, significantly lower than competitors like SpaceX, whose Falcon 9 costs around $62 million. It may seem counterintuitive that a company can offer such low prices while also navigating high capital requirements and extensive regulatory hurdles, which are typical in the aerospace industry. Rocket Lab's ability to maintain low prices while facing these challenges underscores a unique operational efficiency that is not commonly observed in high capital industries. 3. Supplier bargaining power and cost efficiency. The content highlights the strong bargaining power of suppliers due to the limited number of specialized providers in the aerospace sector, which typically drives costs up. However, Rocket Lab's reliance on strong supplier relationships and the outsourcing of approximately 80% of its manufacturing allows it to innovate and potentially negotiate better pricing, creating a scenario where high supplier power does not necessarily lead to higher end costs for the company. 4. Emerging competition versus established relationships. The threat posed by new entrants in the space launch market is significant, yet Rocket Lab's established relationships with major clients like NASA and the U.S. Department of Defense provide a competitive buffer. This suggests that while new entrants might disrupt the market with innovative solutions, the significance of existing relationships and contracts can be a powerful deterrent against potential market share loss, which contradicts the common narrative that new entrants always destabilize established players. 5. Growing customer demand versus price sensitivity. The increasing demand for satellite launches is expected to grow the market to approximately $1 trillion by 2040. However, the content indicates that this increased demand leads to greater price sensitivity among customers Who can negotiate better terms due to the availability of multiple launch options? This juxtaposition raises the question of whether a growing market inherently leads to increased profitability for all players or if it instead intensifies competition and forces companies to lower prices, complicating the anticipated profitability. 6. Technological advancements versus cost of innovation. Although the aerospace sector is characterized by rapid technological advancements that drive competitive pressures, Rocket Lab's commitment to continuous innovation through significant R&D investments contradicts the expectation that such costs will lead to unsustainable financial outputs. The ability to innovate while controlling costs through efficient operations presents a counterintuitive dynamic that companies in high-tech industries often struggle to achieve. 7. Threat of substitutes versus niche innovations. The content discusses the emergence of alternative methods for payload deployment, like air launch systems and lower-cost small satellite launchers. While these alternatives threaten Rocket Lab's market position, the counterintuitive aspect is how these substitutes can simultaneously create a niche market for Rocket Lab. By focusing on specific customer needs and developing tailored services, Rocket Lab could use the threat of substitutes as an opportunity to differentiate its offerings rather than viewing them solely as competition. 8. High barriers to entry versus innovation from small players. Although the aerospace industry has high barriers to entry due to capital requirements and regulatory challenges, the rise of small companies with innovative solutions indicates that these barriers may not be as insurmountable as they seem. This counterintuitive observation suggests that while traditional metrics of market entry difficulty apply, entrepreneurial agility and technological innovation can disrupt established norms, leading to a more dynamic competitive landscape. These counterintuitive insights reveal the complexities and nuances of Rocket Lab's strategy in the broader aerospace market, challenging conventional assumptions about competition, pricing, and innovation in high-capital industries. Important content in the report on Rocket Lab's Electron launch system and its significance. 1. Investment strategy of $100 million. The report highlights a $100 million investment strategy dedicated primarily to research and development, R&D, and technological enhancements for Rocket Lab's Electron rocket. This is a significant figure as it reflects the company's proactive approach to innovation in a rapidly evolving aerospace industry. Many readers may overlook the importance of this investment, viewing it merely as a financial figure. However, this investment is critical for several reasons. Technological advancement. The aerospace sector is characterized by rapid technological advancements. Companies that fail to innovate risk falling behind competitors. Rocket Lab's commitment to R&D not only aims to improve payload capacity by 25% but also enhances its competitive stance against larger players like SpaceX. The ability to innovate can lead to more efficient designs, improved propulsion systems, and ultimately lower launch costs, which can attract more clients. Cost efficiency. Investing in reusable rocket components is essential for reducing operational costs. By developing technologies that allow for the reuse of parts, Rocket Lab can significantly lower its launch prices, making it a more appealing option for customers. This strategy becomes even more vital as competitors continuously lower their prices. 2. For key development phases. The structured approach to development through 4 key phases: R&D, testing and validation, production and scaling, and market deployment is a critical element that some may underestimate. This phased approach signifies several important aspects. Risk mitigation. By breaking down the implementation into phases, Rocket Lab can manage risks more effectively. Each phase allows for assessment and recalibration of strategies based on test results and market feedback. This incremental approach helps prevent large-scale failures that could arise from rushing to deployment. Focus on quality and reliability. The emphasis on testing and validation is crucial in the aerospace industry, where reliability is paramount. Potential clients often prioritize the proven reliability of launch systems. By committing to rigorous testing, Rocket Lab can build a reputation for quality, which can lead to increased customer trust and repeat business. 3. Competitive landscape analysis. The report discusses the competitive landscape and the bargaining power of customers and suppliers, which are often overlooked in favor of more sensational aspects of space travel. Understanding these dynamics is important for several reasons. Supplier relationships. The report notes that Rocket Lab relies heavily on specialized suppliers for critical components. This dependence can create vulnerabilities, particularly if suppliers choose to forward integrate. Some may overlook this aspect, but strong supplier relationships are essential for innovation and maintaining production schedules. A disruption in supply could impede Rocket Lab's ability to meet market demands. Customer negotiation power. As the market for satellite launches expands, customer bargaining power increases. This shift means that Rocket Lab must be agile in its pricing strategies and service offerings to remain competitive. By recognizing the need to adapt to customer demands, Rocket Lab can better position itself to capture a larger market share. 4. Market context and growth projections. The report mentions that the global space economy is projected to grow to approximately $1 trillion by 2040, a statistic that may be easily overlooked. This context is significant because long-term viability. Understanding the growth potential of the space industry helps underscore the strategic importance of Rocket Lab's investments and development plans. A growing market means more opportunities for launches, and companies that position themselves well now will benefit in the long term. Increased competition. As the market grows, more entrants will likely emerge, intensifying competition. Rocket Lab's strategic investments and phased development approach may be critical in establishing a strong foothold before new competitors can pose a significant threat. 5. Emerging threats and strategic responses. The report discusses the threats of substitutes and new entrants, which are vital considerations that many might not fully appreciate. These threats highlight the need for ongoing innovation. Substitutes. With the rise of air launch systems and other alternatives, Rocket Lab must continuously innovate to maintain its market position. The report indicates that companies are developing lower-cost solutions, underscoring the necessity for Rocket Lab to not just enhance its payload capacity but also to keep costs competitive. New entrants. Despite high barriers to entry, the potential for small and innovative players to disrupt the market is significant. Rocket Lab's established relationships and technological expertise give it an edge, but it must remain vigilant and adaptable to fend off emerging competitors. 6. Timeline of events. The timeline provided in the report detailing the development phases is crucial for understanding Rocket Lab's strategic planning. The specific milestones for R&D testing and deployment indicate a well-thought-out approach that aims to synchronize their technological advancements with market readiness. This structured timeline can serve as a roadmap not only for Rocket Lab but also for investors and stakeholders looking to gauge the company's commitment to execution. 7. Customer diversity and market positioning. The diverse client base of Rocket Lab, which includes NASA and various commercial entities, is an important aspect that some may overlook. This diversity reduces reliance on any single client and mitigates risks associated with customer bargaining power. By serving a broad spectrum of clients, Rocket Lab can stabilize its revenue streams and enhance its market resilience. In conclusion, the report on Rocket Lab's Electron launch system implementation outlines critical aspects that go beyond mere figures and timelines. The investment strategy, phased development approach, understanding of competitive dynamics, market growth context, and the recognition of emerging threats all play pivotal roles in shaping Rocket Lab's future. Recognizing these details is essential for stakeholders to appreciate the strategic importance of Rocket Lab's initiatives in a competitive and rapidly evolving aerospace landscape. Key points for in-depth analysis and discussion on Rocket Lab's Electron launch system development. 1. Investment in research and development strategy. Rocket Lab's allocation of $100 million towards enhancing the Electron launch system underscores a significant commitment to innovation. This investment is crucial for refining propulsion systems and developing reusable components, which are essential for improving cost efficiency and performance. The focus on R&D not only aims to increase payload capacity by 25% but also positions Rocket Lab to maintain a competitive edge against established players like SpaceX. The analysis of this investment strategy can delve into how effective R&D spending can lead to technological advancements and market leadership, as well as the potential risks associated with such investments in rapidly evolving aerospace technology. 2. Phased development approach. The structured development plan, encapsulated in 4 key phases: research and development, testing and validation, production and scaling, and market deployment, provides a roadmap for Rocket Lab's strategic execution. Each phase, the discussion could encompass how this phased approach aligns with industry best practices and the importance of adaptive project management in response to technological challenges and market demands. 3. Competitive landscape and market positioning. Rocket Lab operates within a highly competitive aerospace environment characterized by intense rivalry and the presence of both established companies and new entrants. The analysis of Porter's 5 forces reveals the bargaining powers of suppliers and customers, the competitive rivalry, and the threat of substitutes and new entrants. Rocket Lab's strategy to offer cost-effective launch services at approximately $7.5 million per launch compared to competitors like SpaceX positions it as a favorable option for a diverse client base. An in-depth discussion could focus on how Rocket Lab navigates these competitive pressures, the significance of brand reputation, and the role of customer loyalty in securing contracts. 4. Technological innovation and threats of substitutes. The threat of substitutes such as air launch systems and emerging technologies poses significant challenges for Rocket Lab. Continuous innovation is essential to mitigate these threats as customer preferences evolve towards flexible and on-demand solutions. The investment in developing new technologies, including enhancements in propulsion systems and reusable components, is critical for sustaining a competitive edge. An analysis of how Rocket Lab addresses these threats through innovation, alongside a broader discussion on the impact of emerging technologies on traditional launch systems, can provide valuable insights into strategic adaptability in the aerospace industry. Conclusion. An in-depth analysis of these 4 key points will provide a comprehensive understanding of Rocket Lab's strategic initiatives, the challenges it faces within the competitive landscape, and the critical role of innovation and R&D in shaping its future in the aerospace market. Each point highlights not only the operational strategies of Rocket Lab but also the broader implications for the space launch industry as it continues to grow and evolve. Here are 3 famous historical cases that share similarities with the implementation of Rocket Lab's Electron launch system and its strategic development phases. 1. NASA's Apollo program, 1961 to 1972. The Apollo program was a pivotal initiative in the history of space exploration aimed at landing humans on the Moon and safely returning them to Earth. Similar to Rocket Lab's phased development approach, the Apollo program was executed through distinct phases: planning and development, testing, and operational flights. NASA invested heavily in research and development to perfect the Saturn V rocket, which would eventually carry astronauts to the Moon. The program faced numerous challenges, including technological hurdles, budget constraints, and intense competition from the Soviet Union. Just as Rocket Lab aims to enhance its payload capacity to remain competitive, NASA's focus on innovation and reliability led to significant advancements in rocketry and space travel, culminating in the successful Apollo 11 mission in 1969. 2. SpaceX's Falcon 1 development, 2002 to 2008. SpaceX, founded by Elon Musk, embarked on the development of the Falcon 1 rocket, which was designed to be a low-cost, reliable option for launching small payloads into orbit. The development of Falcon 1 involved multiple phases, including design, testing, and eventual commercialization. Despite early failures, SpaceX's commitment to iterative testing and refinement echoes Rocket Lab's strategy of rigorous validation of new technologies. The company faced intense competition and skepticism from established aerospace firms, much like Rocket Lab does today. However, the successful launch of Falcon 1 in 2008 marked a turning point demonstrating the viability of private spaceflight and paving the way for future innovations in the aerospace sector. This case illustrates the importance of investment in research and development as well as the ability to adapt to market demands, principles that are central to Rocket Lab's strategy. 3. Boeing 787 Dreamliner Development 2003 to 2011. The Boeing 787 Dreamliner project represents another significant case of phased development in the aerospace industry. Initiated to create a more fuel-efficient and technologically advanced commercial aircraft, the program involved extensive research, development, and testing phases. Boeing invested heavily, with costs soaring to over $32 billion due to technological challenges and supply chain issues. Similar to Rocket Lab's focus on enhancing payload capacity and production scaling, Boeing's approach included partnerships with various suppliers and an emphasis on innovative materials and systems. The delays and challenges faced during the 787's development serve as a reminder of the complexities involved in aerospace projects, underscoring the need for a robust investment strategy and effective supplier relationships to achieve operational goals. These historical cases highlight the importance of structured development phases, substantial investment in R&D, and the ability to navigate competitive landscapes, parallels that resonate with Rocket Lab's current strategies for enhancing its Electron launch system. Future outlook for Rocket Lab's Electron launch system by 2024. 1. Enhanced payload capacity and market positioning. By implementing the planned enhancements to its Electron launch system, Rocket Lab aims to increase payload capacity by 25% by late 2024. This improvement will not only enhance the rocket's competitive edge against established players like SpaceX but also attract a broader range of customers, particularly those with larger payloads. The projected increase in payload capacity will likely enable Rocket Lab to capture a more significant share of the burgeoning small satellite market, which is anticipated to expand substantially in the coming years. 2. Strategic investment and innovation. The $100 million investment strategy focused on research and development R&D will be pivotal for Rocket Lab's future. This funding will facilitate advancements in propulsion systems and the development of reusable components, which are critical for reducing launch costs and enhancing operational efficiency. As the aerospace industry trends toward more sustainable and cost-effective solutions, Rocket Lab's commitment to innovation will position it favorably to meet evolving customer demands and industry standards. 3. Anticipated market growth and competitive dynamics. The global space economy is expected to reach approximately $1 trillion by 2040. Driven by increased demand for satellite launches from both commercial and governmental sectors. Rocket Lab's proactive approach in enhancing its Electron rocket aligns well with market trends, which forecast a surge in demand for launch services. However, with the increasing number of competitors entering the market, including new startups and established firms developing innovative technologies, Rocket Lab will need to continuously innovate to maintain its market share. 4. Adaptation to competitive pressures. The competitive landscape of the aerospace sector is characterized by rapid technological advancements and aggressive pricing strategies. As companies like SpaceX and emerging startups such as Astra and Relativity Space continue to innovate, Rocket Lab will need to focus on operational efficiency and cost management to remain competitive. The anticipated enhancements to the Electron rocket will be essential for offering competitive pricing while maintaining high reliability and performance standards. Key development phases and predictions. Research and Development 2023. Focus on creating more efficient engines and reusable technologies. Potential partnerships with universities and technology firms to drive innovation. Testing and Validation 2023 to 2024. Extensive testing of new technologies aiming for flawless execution. Potential to establish Rocket Lab as a leader in safety and reliability in the small satellite launch sector. Production and Scaling 2024. Increased production capabilities to meet rising demand. Strengthening supply chain relationships to ensure timely delivery of components, which could involve negotiating long-term contracts with suppliers. Market deployment late 2024. Launch of the upgraded Electron rocket aiming to capture a larger market share. Strategic marketing campaigns targeting diverse customer segments, including small satellite operators and governmental agencies. Conclusion. Rocket Lab's strategic enhancement of its Electron launch system by 2024 is poised to significantly impact its market position within the aerospace industry. By focusing on innovation efficiency and adapting to competitive pressures, Rocket Lab aims to capitalize on the projected growth of the global space economy. The company's commitment to increasing payload capacity while managing costs will be crucial as it navigates a rapidly evolving industry landscape. Overall, Rocket Lab is on a trajectory to strengthen its foothold in the launch services market, enabling it to thrive amidst competition and meet the increasing demands of its customers.